Okay, this stuff here, I would say don't write this down. I'm afraid if you try to write it down, you're going to kind of get behind. And I think you'd be better off just thinking about the stuff as we whip through it. I tried to write a bunch down in advance this morning so that I could go through it faster. But really the notes, the sheet that I gave you, we'll kind of work through that together at the end of this. And you'll be better off time-wise for that. Does that work for you? Okay, so the first thing, it's called completing the square, and just kind of wanted to go over like what in the world are we talking about with this completing the square. And so I slurped a couple pictures out of the book. This is one of them. And so if we were to take, and let me erase my little chicken scratches there. If we take this thing here, and if you look at those sides both being x plus 3, what they're really trying to say is that this here is an x, and this would be like a 1, a 1, and a 1. Like those lengths. So we have x plus 3 for the length of that side. You with me? And then this here would be like the x, and then I have another 1, a 1, and a 1. So give me x plus 3 for both lengths. Good? Now, if you think of that, if we wanted the area of this, we'd multiply the length of those two sides, right? So we'd have x plus 3 times x plus 3. And when we multiply those, we do FOIL. We FOIL the thing. Well, when you FOIL, do you agree we do x squared as our first bit? X squared is going to be which one of those squares are rectangles? Agree that's this big one? Agree that's going to be the x times x, or x squared? And then when we do the outside and the inside, outside gives me plus 3x, inside gives me plus 3x for a total of plus 6x, right? That's going to be these three things here. So this one, this one, this one, that. That each of those, if we look at, say, this one here, do you agree that's going to be 1 tall and x wide? So this purple box here is 1x. So I have 6 of those little 1x's in this part there. That's my outside, inside. Yes? Nods. Okay. And then when we do the last term, it's plus 3 times plus 3 gives us 9. And that's going to be those 9 little boxes in the lower right. This here is 1 and 1. Oops. 1's going the wrong way, but 1 and 1. So that would have an area of 1. So I have 9 of these little 1s. You kind of with me for those? So that's kind of the first part. So I found a lot of people when I was doing Algebra 2, when we talked about completing the square, they didn't really have a clue what we were talking about. But this is at least the square that we're talking about. Yes? Okay. Now why completing the square? Must have my picture down here. That sometimes what happens, and we're going to get to this a little bit later in the notes, but we said this was my x squared. Sometimes you'll have your x squared, you'll have your plus 6x, but the thing we had at the end, I think it was blue, wasn't it? Yep. The thing we had at the end is missing. This part here is missing. And we have to be able to come up with, okay, I need to have a 9 there. That I need to know that in here I have an area of 9. Because now this thing, we could factor and get back into what we had before, the x plus 3 quantity squared. So I might have lost you a little bit there, in which case I wouldn't stress about it much. But the point is, if we have all of this orange stuff, oops, wrong thing. If we have all of this orange stuff here, we're trying to figure out how can we figure out this missing part here to complete the square so we get a perfect square trinomial so we can factor it. Good? And if you lost some of that, I wouldn't stress about it. Let's just go and actually do some. So then here, I guess a question. So we're learning the process today. You don't need to know the part we just went over. But if you do, you kind of get like why it works a little bit more. And I think that that's nice. For me, that helps me kind of think through what's going on. But if you miss that, you still can do what you need to do to get your A. It's just a little bit more like voodoo magic as opposed to, oh, I have this square and I'm missing this, so I'm going to throw that in there. Fair enough? All right. Here's the part moving on. Okay, so this top part in blue, we learned those 2 chapters ago. We used them in the last chapter. They should look familiar to you, right? The binomial squared theorem, I think we call them. And the only difference between the top line and the bottom line is what I have there in green. That if I have an x plus y here, quantity squared, my b term, this middle term, is going to be positive. If it's an x minus y quantity squared, I have my negative. Good? That's going to come up later. So one thing that you could do is you could say, all right, I have this x plus 3 quantity squared. You could do what I did in that last page and say, all right, that's an x plus 3 times an x plus 3. Then you could go through and FOIL and all that. Or the really good people look at that and they say, okay, And most of us don't actually do this, but this is most similar to that top one, right? So this first term here is going to be just whatever's in that x spot, which is x squared. So I have an x squared, yes? The middle is going to be, all right, plus 2 times x times y. So 2 times this thing times that thing. So I have 2 times 3 times x. That gives me my plus 6x. Still good? Then the very last part is this plus y squared. Well, my y is right there. So it has to be this plus 3 squared. And now I have this ugly jumble, but you kind of with me on that? Okay. All right. Now, what we want to do in this section is we want to be able to do that backwards. We want to say, okay, given that, ooh, I wish I didn't make that so ugly. Let me quick fix it. Okay. The point of doing that last part is I wanted to draw emphasis to a couple things. One, that to find that x at the beginning, the x is just going to be whatever's at the front of my binomial is just going to be the square root of this x squared, right? And we've been doing that as we did the factoring. So we know for this bottom one here, this next one here, this has to be an x. Agreed? The sign, we can figure out the sign in the middle, the sign that goes right there, by looking at sign number 1 or sign number 2. Sign number 1 gives us that. So because this is a plus, it's a plus like that, so we need to have a plus on the inside. So this here is going to be my plus. You with me? If this had been a minus 6y, then it'd be like this one, so we'd have to have a minus. Then my last term, this 3, so going up here, I could get this 3, so now I'm in this top line here. I could get that 3 one of 2 ways. What's one of the 2 ways? I could do the square root of this thing here at the end, so I should have probably wrote that as a 9. You know, that is going to be this thing here, the square root of it. So this one, if I have a 9, square root of 9 gives me a 3, right? Because I have a y squared over here, and I'm trying to figure out what y is. So I just square root my y squared. I go and square root my y squared, I get the y. Okay, I'm making this too confusing. The other way, what could you do to this 6x to turn it into a 3? Divide it by 2. Because that middle term is 2 times y x's. Yes? Okay. I took too long. Let's just go through it. You can do these things. All right, this next one. In the parentheses, I have to have first x. My sign has to be plus. Number has to be 2. And you get the 2 from either doing the square root of the 4 or this 4 divided by 2. Agreed? All right, the next one. In front, I have to have a x minus 5. You get the 5 by either doing the square root of the 25 or divide that thing by 2. Good? If I were to try to mess with your heads, because you made that sound way too easy, x squared plus 2x plus 1. What's that going to be? Oh! Okay, but you get it, right? Even when it looks weird, because you get the 1 just by doing square root of 1 or 2 divided by 2. Mess me up, but not you. 2 divided by 2 gives you the 1. Okay, good? One step more, and then we get into the fun part. Okay, now we get to hear this. Yes, I get bored listening to myself, okay? All right, this here. Can I take this x squared plus 8x? Well, in front I'm going to have x, right? The sign has to be plus. And the number here kind of should be a 4. But does that work for just this x squared plus 8x?
No.
I'm missing what has to go here? Yep, plus 16. That if I had this plus 16 there, then I could take and change this back into that, right? Because that plus 16 makes this here a perfect square trinomial, which then you could write as a binomial squared. So the next skill you need before we get into like really doing the section is say, okay, what do you have to add? So if I were to have over here an x squared plus 10x, what would you have to add over here to be able to change it to binomial squared? Have to add a 25. Because over here my number right here is going to be a 5. You get that from the 10, right? Half a 10. And 5 squared gives me has to be a 25. Now if I add a 25, going back a little bit to when I was here, if I added a 25 to the right side, what do I have to do over to the left side to keep it equal? Technically, I can only add 25 to the right if I'm adding 25 to the left side. Agreed? That would keep the whole thing equal. And we'll kind of come back to that. All right. Some other things. What would you have to add? If I had an x squared plus 6x, you'd have to add a 9. Because half of 6 is 3. 3 squared, you have your 9. If I were to give you an x squared minus 30x, what would you have to add? If you can't do it in your head, just say it'd be this number. Add 15 squared. So half of 30 gives me the 15, so you'd have to add 225 to both sides. If I had an x squared plus 2x, you'd have to add 1. Because half of 2 is 1, 1 squared is 1. If you were to get like an x squared minus 7x, you'd have to add 3.5 squared. I didn't even write that down. So you'd have to like go through and figure out what that is. But you'd be adding a 3.5 squared. Okay? Then from there, now, so here's the top of that sheet. If you want to write stuff down either on like a sheet or maybe the top of the sheet I passed out to you, I would write down something like this here. I'd say, so if you have your sheet, maybe at the top, say, given x squared plus bx, this here has to be, now I don't have a number anymore, I just have this bx's. So what do you need to do to b to come up with what goes in that blank? Divide b by 2, and then square the number. So it's b over 2 quantity squared. Or if you would prefer, I wrote it this way in my instructions. I wrote 1/2 b quantity squared, kind of whatever makes the most sense to you. 2 ways to do it. How are we doing? Okay on that? So that's kind of the first thing. All right. Now here's the steps that we're going to be doing for completing the square. So Algebra 1 notes. And I'm going to go through, you have right below an example of all these different steps. So I'm going to kind of be jumping page to page for mine. So first thing is rewrite so one side has only x terms. And what I mean by that is this first thing here, that I'm starting out with this 3x squared minus 5x minus 2. We want to get it so I only have x values, or things with x's on one side. So the way I get that is I add 2 to here. If I add 2 to the left, I have to add 2 to the right to keep it equal. And then it gives me just that line there in black. You still with me? So I have 3x squared minus 5x equals 2. No questions so far. Then second step. If you have a number in front of the x squared, because we're saying it's ax squared plus bx now equals negative c. So if it's like a 5x squared, if it's a negative 17x squared, if it's a 2x squared, you're going to have to divide by that number that's in front of x squared. So if you had a 2x squared, divide by 2. So if I jump here, I have a 3x squared minus 5x. I'm looking right here. So 3x squared minus 5x equals 2. Because of that 3, I have to divide this by 3, divide that by 3. Yes? If people make a mistake, this is similar to what we did in Algebra 2. I'd say 60 to 70% of the mistakes happen right there in that step. And it's this here with a 5. People get the x squared, but they just leave this as a minus 5x. You have to divide all of the left side by 3 and all the right side by 3. You with me? So kind of keep that in mind. You have to divide all of the left side. It's the only way to keep it equal is divide all of both sides. All right. Now, we want to complete the square. And there is different ways to do it. I've thought it through. I think this is the easiest way to do it, just following my steps here. But so we add that, we get this b over 2 squared, what we were just doing on the slide before to both sides. That, okay, I have right here, I want to make this side here a perfect square trinomial so I can change it into a binomial squared. So to do that, I take half of this number and I square it. Now, all my examples didn't have ugly fractions. Our book seems to love the fractions, so I'm teaching it to you that way. But if you have this 5/3, 5/3 divided by 2, do you agree that's the same as 5/3 times 1/2? So that's the way I think of it. 5/3 divided by 2, same as 5/3 times 1/2, or kind of I wrote it as that 1/2 times b. When you get that, it's 5 times 1 is 5, 3 times 2 is 6. I just get this 5 over 6. You with me on the 5 over 6? If I take that 5/6 now and square it, that 2 applies to the 5 and the 6, so I get the 25 over 36. You with me for that part? And if I add the 25 over 36 here on the left side, to keep the equal sign there, I have to add it here on the right side as well. Good? And they won't all have nasty fractions like this, but some do. All right, so now that I'm here, I should jump back to my step. I did step 3, I completed the square. So now I have, going back to that very beginning, I have this whole rectangle, or this whole square rather. Now I can go back and change it to like some binomial squared. So we're just doing what we did before, saying, okay, I have this here, I take and square root my x squared, that gives me my x. I copy this sign down for that, and now you have one of two options. You can square root this fraction here in blue, so square root of 25 is the 5, square root of 36 is the 6. Or you could take and do half of, if you'd rather, you could take this middle part here and just cut it in two. The beautiful part is you already cut it in two right there. So really just what this is going to be right there, the y in that x minus y quantity squared, is always what you had before you squared it to get c. So you can save yourself some steps if you kind of recognize that. And then we get to the, all right, now we need to add these two things here together. So I made it so I had common denominators by multiplying by 12 right there. Now I could say I have 49 over 36. Remember the difference between adding fractions and multiplying? Adding, you need common denominators. Multiplying, you don't. So multiplying don't have common denominators in multiplying. Adding, you need common denominators. Then you keep that denominator the same, and you just add the two numerators. So essentially you have 24 plus 25 gives you the 49. Okay? I'm probably going too slow. I don't want to lose people. Now, the last part is, here in black, we have a similar thing to what you guys were doing in the last section. We have a quantity squared equaling a number. So if we want to find zeros, if we want to figure out what are the x-intercepts for this parabola, now that I have something squared equals a number, you do the steps from yesterday. We square root both sides. Square rooting this left side just gives me absolute value of what's inside. Square rooting the right side, fortunately the book usually hooks us up, so I will too. And you get like a nice square root of 49 is the 7, square root of 36 is the 6. And now we're exactly where we were yesterday in the homework. We say, okay, inside here, this could have been a positive 7 over 6, that's this part. Or this part here inside, the absolute value could have been a negative 7 over 6, that gives us, this one here. And then you go through and just solve it for x. Add 5 6 to both sides, and you get your two x values. Okay. Your look probably says that, oh, you feel like your brain's swimming a little bit? And this is why I told you the homework is not due tomorrow. We're going to have a day in class to kind of work on it, because this is tough stuff. And why I typed up all the sheets, I gave you the example, but let's try to go through and do one. So, backside of your sheet. You have one we get to do together. We get to share the love. Actually, I probably want that bigger. Oh, come on, you pessimist. Okay. Try. Now you try. Now you succeed. Now you show off. All right. First step. Step one was we want to only have x values or things with x's on one side. So we need to do what to both sides? Perfect. So step number one, we subtract 24 from both sides. And then that leaves us with a 2x squared minus 16x. I'm going to leave a little space because we're going to end up adding something in there maybe soon. Equals my negative 24. Still tracking with me?
Yes.
Okay. Second step. So you could flip your sheet over if you wanted to, but second step says if there's a number in front of your x squared other than 1, we want to get rid of that number. So we have a 2x squared, so we divide everything by a 2. So I have an x squared. I'm tempted to do it wrong, but I don't want to confuse you. 16 over 2 gives me minus 8x's equals a negative 12. Good so far? Yeah, so far. It'll get worse. All right. Then next step is figure out what goes right here. What number goes right there? You're good at this. What do you do to 8? 16. Take the 8, cut the 8 in half. You want to do half of b, and we're looking at like a ax squared plus kind of bx plus c. But we want to cut that 8 in half. Half of b is half of the 8, half of negative 8 technically. So negative 4 squared gives me a plus 16. If I add 16 to the left, I must add it to the right, which is beautiful because now we're back into positive numbers. So we have then, I'm going to rewrite it over here and just say this is 4, which by the way, showing your work, it takes some steps, but it's the easy way. Trying to do like multiple steps in your head, please don't. Just please, you get fast. I can do these buggers really fast. Once you learn the steps, you just kind of through the steps. Please show your steps. Okay. All right. Next one was we want to change this baby to a binomial squared. It's going to be what?
X
Minus 4. Because we copy down our x, well, kind of like that. Copy down your minus sign. Then you could say half of 8, or you could do square root of 16. Either one will give you the 4. Good? On the right side, we still just keep the 4. So I can get rid of a little bit of the clutter there. All right, now we're to where we were yesterday. We want to solve for x. What do we do to both sides? Perfect. We want to get rid of that squared, so we square root both sides. And what happens is this square root cancels with my 2 there, with my exponent. And it doesn't just leave me with the x minus 4. It leaves me with absolute value of x minus 4 equals 2. And now we know that it could have been an absolute value of 2 right there. So one solution is x minus 4 equals 2. The other thing that could have been in the absolute value is it could be absolute value of a negative 2 right here gives me my positive 2. So that x minus 4 could have been a negative 2. And then last step, what do we have to do to both sides of both of those buggers? Add 4. So we add 4 here, both sides, and we get a x equals 6. Or we add 4 to both of these, and we get a x equals 2. Throw an or in between. So that right there are our two x-intercepts. Those are the two places where the parabola crosses the x-axis. And you get it, right? A lot of you, it looks a whole lot better without the fractions. Which, if we have one more example, probably tells you this thing with the stuff. Okay. Step number 1. Step number 1 is already done. Good eye. Step number 1 is get it so you only have an x squared and an x on one side. Did that for you. Step number 2 then was... Yep. So step number 2 is done also. We have a 1x squared, so we don't have to do anything with that. Step 3 is, I need a little bit more space, x squared plus 14x. Step 3 was complete the square. Come up with that number right there. And I'm getting 49. People agree, disagree?
Yes, I agree.
Yep. Because I cut my 14 in 2, gives me 7. Square 7, I get my 49. And right now I'm forgetting to... If I add 49 to the left, if I have to add it to the right. So I'm going to just quick rewrite this a second. X squared plus 14x. This is a step that some people do combine into one, and you can get away with it. But I have a 64 there, fortunately. Next step. We want to take the left side and change it to a binomial squared. So some people do skip this. What I was starting to say is some people skip writing that, and they just say this binomial squared equals the 64. X plus 7, everybody agrees it makes sense? And now you're to what you were doing yesterday successfully, so we just square root both sides. So I guess I didn't give you the nasty fraction. I apologize for that. So absolute value of x plus 7 equals 8. And now we could say, so x plus 7 could equal 8, or x plus 7 could equal a negative 8. And last step, we just go through and subtract 7 there. So I get a x equals 1, or x equals negative 15. Oh, please don't let me lose you yet. I have two more things to say and then I'm done. But are we okay on this? Yeah. And when you get the nasty fractions, work through them. I'll help you. Here's the last 2 things. Actually, I just have one, because one of them is see this sheet for the steps. So I would encourage you, as you start doing the homework, keep this page here kind of close by and refer back to it. I'm hoping by the time you get done with the homework, you can start to just see the pattern and go through it without the steps. Because on the test, you're not going to have the steps like right there for you. But the other thing I want to say is this, and it kind of came up yesterday in the notes too. If you end up with the square root of a negative number, you have no solution. So in other words, if when I get to a part like right here, so if you end up with something like this, Say instead that was a x plus 7 quantity squared equal to negative 64. You can go through and square root both of those and get your absolute value of x plus 7. But when you do the square root of negative 64, the answer in Algebra 2 class is going to be 8i. It's an imaginary number. But for us now, what it's saying is there is no real number. There's no possible number there that if you square it gives you negative 64. So what you have is you have a parabola like this. It's a parabola that nowhere crosses the x-axis. There's no x-intercepts. So you may want to just scribble in your notes somewhere this whole, if square root of a negative number, there's no solution. Or you could say, if you wanted to, no x-intercept.